Hello students, we are going to study the diode application in clamper circuits. Clamper circuits are also known as level shifter circuits, which shift the AC input signal to a DC level without changing the shape and peak-to-peak voltage of the AC input signal. The components required for this practical are capacitor of 104 picofarad, resistor of 1 mega ohm, diode IN4007. Function generator will consider frequency of 1 kHz sine wave and peak-to-peak voltage to be 15 volt. Digital storage oscilloscope to observe the waveforms, where the channel 1 will be observed for input waveform and channel 2 for output waveform. There are total 6 types of clamper circuits. The first type is positive clamper circuit. This circuit shifts the AC input signal to the positive portion of the input signal. If we observe, the V maximum of input signal, that is plus 7.5 volt, is shifted to the 15 volt, and the V minimum of input signal, that is minus 7.5 volt, is shifted to 0 volt. Here, the input signal is applied at the terminals of capacitor and diode, and output waveform is observed across the resistor. Let's implement this circuit to observe the output waveform. The circuit connections are like this. The input is fed from the function generator to the circuit, and the same input signal is observed in the channel 1 of the DSO. Output is taken across the capacitor, diode and resistor junction and given it to channel 2 of the DSO. These are the output waveforms. As we can see, the input signal, which is shifted to the positive portion of the input signal, and if we observe, the channel 2 V maximum voltage is coming around 14.4 volt and V minimum is coming around minus 600 millivolt, which is nothing but 0.006 volt. The second type is positive clamper with positive reference voltage VR. This circuit shifts the AC input signal to the positive portion at positive reference voltage. If we observe, the input Vmax, that is 7.5 volt, is shifted to 18 volt, and input V minimum, that is minus 7.5 volt, is shifted to 3 volt, which is the positive reference volt. The circuit is same as basic positive clamper. The only component which is added is reference voltage, that is positive reference voltage below the diode. Let's observe the waveform. Positive reference voltage. The positive reference voltage is fed to the anode of the diode, and negative of the voltage reference is fed to the resistor. The output waveforms can be observed like this. As we can see, output Vmax is 17.8 and V minimum is 3 volt. So this circuit is shifting the AC input signal to a positive reference voltage, that is 3 volt. The third type is positive clamper with negative reference voltage. This circuit will shift the AC input signal to the positive portion at negative reference, that is minus 3 volt. Let's observe the waveform. In this circuit, we will just interchange the positive and negative polarities of the reference voltage. As we can see in the waveform, V minimum is shifted to around minus 2.8 and V maximum is shifted to 12.40. Fourth type is negative clamper circuit. This circuit shifts the AC input signal to the negative portion of the input waveform. That means the input Vmax is shifted to 0 volt and input V minimum is shifted to minus 15 volt. Let's observe the waveform. This is the circuit of positive clampers. If we want to observe the negative clamper circuit, we just need to reverse the diode. As we can see, V maximum is coming around 0 volt and V minimum is coming around 14.6 volt. So this is shifting the input signal to the negative portion. Fifth type is negative clamper with positive reference voltage. This circuit shifts Vmax of the input signal at 3 volt and V minimum of the input signal at minus 12 volt. Let's observe the waveform. The positive reference volt, that is 3 volt, is connected between the diode and the resistor. If we observe the waveform, we can see the V maximum is shifted at 3 volt and V minimum is shifted at minus 12 volt. The sixth type is negative clamper with negative reference voltage. This circuit shifts the Vmax of the input to minus 3 volt and V minimum of the input signal to minus 18 volt. Let's observe the waveform. In this circuit, we will just interchange the polarities of the reference voltage. From the waveforms, we can see that Vmax is coming minus 3 volt and V minimum is coming minus 8 volt. In this way, we have studied, implemented and